Hello. Well, as you may know, I run audio and videotape transfers, and I do some very obscure formats, including this extremely rare one. It's called SVC, or Super Video Cassette Recording, Super Video Cassette, and there's only one model of machine ever made for this. I have one and it has worked, but I've just pulled it out to run a customer tape and it's failed on me. So we're going to have to get stuck into this extremely obscure machine for which service manuals are poor quality and in German, and I know they have mistakes in them. So this is going to be tricky. So it's the SVR4004 GB in this case, and it's the same form factor of cassette as used in Philips VCR-N1500 and VCR-LP N1700, but there's an extra little bit of plastic there which tells this machine that it's the right kind of tape for recording its extremely long version of recording time. It can do up to 4 hours. And this machine was working last time I used it, which would have been probably a couple of years ago. I have demonstrated it on YouTube. And when I power it up on my isolation transformer, we'll take this cover off for a moment. Everything looks normal. We have the flashing clock display as we'd expect, and then we should switch this on and then press playback. But when I switch it on, the display goes out, and if I switch it off again, the display either stays out or sometimes just lights up with an 8. I had it doing earlier downstairs. So that says to me that the power supply is tripped out. So what's happening is when I switch it on, something's going short circuit. Could well be a tantalum capacitor because they have lots of them in here. So let's have a look. If I power cycle it, give it a little bit of time to rest, it will probably get back to flashing the clock. There we go. Flashing the clock again. So the power supply is recovered, but again it will just trip out. Alright. This isn't much fun. Let's take the lid off and have a look. We have to take this sharpness or contour control off the top. There's some kind of bodge board here installed by the manufacturer. Don't know what that does. And there's a board I've installed here which provides composite video out at the back, because the video signal inside to drive the modulator is not the correct amplitude and impedance to drive video out here. So that all works normally. Right, so what is the problem that when we switch it on, everything shuts down? We could look at some supply voltages here, but I have a feeling that the wiring for the connector here may not be correct in the manual. Starting, well, somewhere, this pin 8 here, it says for, well, it's syscon for process control. So let's power it up with and without the power switch operating and see what voltage we get there. So with just a flashing clock we get nothing there. I suspect I'll get nothing when I switch it on as well. Yeah, nothing. So I think it's nothing when it's off, which is correct, and then nothing when it's on because something's tripped out. Right. The relay is probably not being energized. Let's see if that's true. Pin 4.1 is about, I think, minus 25 volts. It's very hard to see. The diagram's just not that clear. I think it's minus 25 volts on connector 4.1, and I guess that will also not exist for the same reasons. Okay, so power the machine up, nothing there, switch it on, and it pops up for a moment to something. Okay, so the relay is not being energized, or only being energized for an instant. Mind, I'm not hearing it click. And 4.1, the minus 25 volts, is actually prior to the relay there. So it says we're not getting anything here. We may have blown the fuse. I think it's highly likely that a short circuit is possibly taken out that fuse. And if that's so, that's going to be tricky, because it says, if that's the right one, it's a 50 milliamp fuse, and that's not the sort of thing I have in stock. Another part of the schematic says it's a 630 milliamp fuse, so we just don't know. See what I said about these manuals are full of mistakes, but it's the third fuse down, we think. Let's see if we can find that. Well, it's all a bit awkward, but I think I'll just test all the fuses as I'm here. Second fuse down is blown. Right. And I think it's been blown pretty thoroughly. The wire is completely gone, so it's not like it's just aged. It's gone for a reason. So that's time delay 1 amp, and that's fuse 442. Okay, number 442, that goes straight to a 5-volt regulator and some other things, B47 and a regulator. So it goes B47, which is 12 volts, and to a 5-volt regulator. And there's the fuse 442, which is the one we've blown. So either there's a short circuit on, well, either the 5-volt regulator's gone short circuit, because a short circuit on it would not blow the fuse on the output, or, and is more likely, the 12-volt line here is feeding a short circuit. So let's have a look what resistance we find from that fuse, which has now been removed, to ground. So this is the output side of the fuse here. That's the input side from the transformer, so that will read low resistance to ground anyway, probably. So let's see on the output side. Oh yeah, that's pretty short circuit. So that'll be why the fuse blew. So either the regulator has failed, which I think is this one, unlikely but possible, or there's a 12-volt short on B47, this point here. So this will also read short. Oddly enough, it doesn't. Oddly enough, it doesn't. So we've got a short on the input to the 5-volt regulator. Ground there. No short circuit on its output, but its input is all. No, I'm misreading that because that is pin 7. No, that can't be right, because the input side is grounded, right? So let's follow the traces. The trouble is, it's just not clear. The quality of the scans is not clear enough. I read that B47 is connected to the input of that regulator, but I'm not believing that's true. Well, it doesn't. So just keep finding things that are different and wrong. Because if it did, where this puts this line here, which is the input to the regulator, would also be short circuit here at pin 7. And it's not. So it's clearly not connected where it says it is in the manual. So if there are no other connections, then the only two components on this short circuit line are the regulator and the capacitor. And unlikely that an electrolytic capacitor is going to go dead short, so most likely the regulator's gone dead short. Let's desolder it and have a look. Actually, there is another wire on here. There's a brown wire on the board going some random place, and we don't know which. So I'm going to have to desolder this point here to try to find out where the short exists. Okay, I have desoldered the wire, which you can barely see here. That wire here is desoldered. So we can now find out if the short is on the wire or on the regulator. So going to the regulator, it still appears to be short. And on the wire to whatever signal it is not short. So we do indeed have a short 5-volt regulator. That's probably the best possible outcome, apart from the fact I don't think I have one to hand. Yeah, the trouble is, I was going to buy a load of 5-volt regulators, and it turns out that an awful lot of the ones you buy are fake. So I had put off buying some 5-volt regulators, and now I wish I had. Just buy them from RS or somewhere. Oh, that's odd. With the 5 volts regulator desoldered and the wire going off to heaven only knows where desoldered, we still have a short circuit. What, the capacitor's gone short? Well, you know, in all my years of working on electronics, the only time I've ever had a large value electrolytic capacitor go short is when I've had this type with a metal can like this on the outside, and there's something about the way it's constructed that can allow them to go short circuit. So yep, that's our fault. 2200 microfarad 16 volt short circuit electrolytic capacitor. So there's our bad capacitor, 2200 16 volt, and we've got 2200 25 volt, 105 Celsius. So that's a higher quality modern component to put in there. Okay, that's soldered in. I've resoldered the that wire and the 5 volt regulator, and I have a 1 amp fuse. There is this insulator floating around in here, and I have to confess I don't know exactly where it's supposed to come from. Right, so let's switch it on and see if it stays on when I switch that button. No. Oh dear. So if we output that fuse, we should get 12 volts at all times. Yep, that's working. So there's some other fault now. What about the output from the regulator? Did we get 5 volts there? Yes. Do we still get 5 volts when we switch it on? Yes. So we have a separate fault. It seems odd that, doesn't it? That after finding and replacing a defective component, and that allowing other power rails to come up which weren't there because of the defective component, that the symptoms look exactly the same. 2 faults. It's just a bit odd. Okay, anyway, let's try and find out what's wrong. The fault symptoms aren't exactly the same as they were before because we now have a display on the channel, but still it won't do any functions. Okay, the wire link, I now see where it goes. It goes from the red wire link on the regulator, and it goes from here to here, and that's absolutely fine. Right, the schematics are just plain wrong when it comes to pin numbering around B4. It's all complete chaos. It's switching this display on and off, but it's not energizing the relay. If you completely reverse the direction of the pins on this connector, it starts to make a lot more sense. And indeed, later on in the service manual, there is a diagram showing that connector with pin 1 on the right, on the edge. So that's the case. But the schematics which show that here are for a different version of the board. It doesn't have the fuse that the one that we blew actually. There's not there at all, and the capacitor and 5 volt relay, 5 volt regulator are not there at all. But that's okay because that's not the area we're now struggling with. We're struggling with this signal here that's supposed to switch the transistor, the relay on, and that now is on pin 8, and there's no question of that. It's actually on pin 8. Right, so we actually understand a little bit more. And when you look at these schematics, you can now actually take correctly the pin numbers that it gives you here. So pin 8 of number 4 is VCR-LP 23, which you could say doesn't help very much, but we need to find out where that goes on the main board below. And we have some overall schematics here of the whole, well, we have some schematics of the whole board, but they're just unreadable. So you can't make head and tail of it, it's just too small. The schematic also shows us the on-off switch, but it doesn't help at all because it's just got various signals going to unknown places, and again none of it's really legible, so we don't know where those signals go. So I have to take the bottom off. Well, it's a piece of typical Grundig nastiness. I mean, that's just a nasty board. What were they thinking of? It's just an evil thing to work on. The schematic does explain that you can get extender cards, I think, for the various boards, but of course we don't have such things. They were all lost 40 years ago. So we're on our own a bit. Okay, I've managed to work out a little bit. Our pin 23 from the Syscon is the voltage which should go up to about 10 volts to switch the relay on. It says B48, which is wrong, that's B43. And I'm on that signal here where it meets the board. This is B43, and I've found a pin where it connects to, and it weaves its way around here to the Syscon, which is more or less just a microprocessor on a board. There's not an awful lot on that one. And the way this connector works, and get this off, is that it oscillates one side than the other, and I think that's pin 31, 30, 29, 28, it's marked 28 there, 27, 26, 25, 24, 23, yes, there we are. And that's the one that's not going to 10 volts. And it should do. So it's not being sent to 10 volts. The first thing to check is that the board has supply voltage. So I think this board runs on 15 volts. Let me just check that. Okay, well pin 8 should go to 15 volts when it's on, so we'll check that. That's via some switches. That's the on-off switch. Okay, so pin 8 should go from 0 to 15 volts when the on switch here is pressed. So we're looking for this pin here to go to 15 volts, that's pin 8, when the on switch is pressed. So I'll power it up with the switch off, we get no voltage there, switch it on, still nothing. So that 15 volt there is missing. That comes from this on-off switch. So we need to look at some more of the wiring in that direction. But also I think there should be a permanent 15 volt supply. Maybe that's missing. There's a permanent 15 volt supply, pin 3 of the top connector. Let's just check that. Okay, we have a top connector here. Which end is pin 3 is something of a mystery. I think is that one. It's hard to tell because there's a pin 1 that isn't used. So let's just check we've got 15 volts on that. Hope you can see the meter. No. Right, so there's a 15 volt rail missing, we think. But it's a little hard to tell if I'm on the right connector. So we may need to go back to the power supply and look for the 15 volt rail. The always 15 volt rail output. And I have to keep using Google Translate feature to find out what all this means. I do know a little German, but not enough. Plus 15 VO. We're looking for the plus 15 VO line, which should be always 15 volts. So which pin would that be on? It may be D, not O. Struggling with the low quality scans again. This is slightly better than some of the other ones, this page. So I think it's connector 1, pin 10 is plus 15D, I think. And where's connector 1? It's not this top one, that's number 4. Connector 1 is at the bottom. So I'm going to struggle. I'll have to take the power supply out, I think, in order to be able to look at that voltage. Yep, I think I have to take the power supply out in order to be able to get down there. can just barely get to some of the connectors in there. Oh, what an evil thing to work on. It almost feels like they knew no one was going to be stupid enough to buy these things, so don't worry about serviceability. Right, pin 10 is 15 volt, but we don't know which end is pin 10, and even if the schematics tell us which end pin 10 is, it's 50-50 whether it's right. I think this is it. I think that's supposed to be pin 10 there. Let's see if we get 15 volts on that connector, even with this in the off position. We get 4 volts. Nah, I'm probably on the wrong pin. 32 volts on the other end. It's just an unknown. There's just too many unknowns here. I think this end should be 15 volts. Is that right? I don't know. It's too many unknowns. 36 volts at one end it's supposed to be. Well, I'm reading about 33. Then next to that should be 15. But I don't know if that's all the time. Let's read that one. Nope. And another one that should be 15 at some times. Nope. 15 at some times. No, we're not getting any 15 volt rails. 2 grounds. You agree with that. 26 volts on the second end one. Do we get that? No. This is our 15 volts supposedly. Oh, it is 15 volts. There we do have 15 volts. And it switches off. That's right. Okay. And it collapses when I switch the unit on. Right. We did have, when it recovers from its trip condition, we do get 15 volts there. Let everything recover. Switch it on now. We get 15 volts. But as soon as I switch the unit on, it collapses to about 3 volt or some low voltage. And when I switch it off, it sort of creeps back up a bit. Right, so there we have it. That's our always 15 volt line, and it is not working. It's collapsing when I switch the unit on. The 15 volt supply is derived from this IC here. It's a UA723, same as LM723. And I could start looking at some voltages around there, but I'm going to do a preemptive strike. I've had a lot of those ICs fail in similar machines like the N1700. They fail a lot, so I think I'm going to fit a socket, and I have the option of replacing the chip easily then. So I'll just replace that chip anyway, I think, and see where we are. If it doesn't fix anything, at least we've eliminated something. So that's a bit awkward. It's a bit difficult to get to. It's sort of in here, and I haven't got particularly good access, but I can desolder the pins there and fit a socket. Given a fairly poor access on the other side, I've actually fitted the socket and the IC together. Wouldn't normally do that, but otherwise I might have a bit of trouble pushing the IC in. Not impossible, but tricky. Okay, I'll be surprised if that's changed anything, but at least it may have eliminated something. So let's just power it up. I didn't even see the clock flashing then. Oh. Is that worse? There's a couple of voltages I want to measure around the UA723. Not many voltages are given anyway, but we should see 22.6 volts or so on pin 12, and on pin 13 we should be less than that because we've got the transistor. So let's start with looking at pin 12. So we should see about 22.6 volts when powered up. We're seeing about 26, little high, but then it's probably no load. So we should see a little bit less than that, 0.6 volts less or thereabouts, on pin 11 next door. Actually, I'll pick it up on this track over here, slightly safer. So we should see about 24 volts something. Yes, we are. The only other voltage we're really given is pin 6, which should be around about the 7 volt area. So we should get something like 7 volts on that one. Yes. So everything looks about right on the UA723. So we need to look at the transistor, and we should get 15.4 volts or so out of its collector there, where it's regulating. So it's a PNP transistor. Let's just find it. So I believe this is our 15 volt output. Let's just see what we see. 15 volts, yes. And what happens to that 15 volts when I press the on switch? It collapses and doesn't really come back. Right. So in that fault condition, what's happening to the input voltages? So pin 12, which is our input voltage of 22.6, presumably that remains even in the fault condition. So that's, well, 25 volts. Switch this on, and yes, it stays the same. And pin 11, which goes to the transistor base. So it stays, it's about 24 volts. I switch it on, and it goes up, which of course will switch the transistor off. So we need to understand why the UA723 is shutting the transistor down. Let's just let the voltage dissipate for a moment. I'm going to just switch this on there and check to see if we can see a heavy load on that 15 volts. So I'm not sure what resistance we'd expect in there, but not terribly, I don't know, some resistance of some hundreds of ohms, maybe 100 ohms, something like that, and maybe a bit less. Right, I've actually got the top connector disc removed, so I'm not sure I'm going to get all the loads I should get, but it's still behaving much the same way with the connector off anyway. So let's switch this on. Aha, 1 ohm. Right, when we find out why we're getting a 1 ohm load when that's switched on, we will have found the short circuit. Okay, so I'm set up. I've put the power supply sort of roughly back in place. I'm set up so that when I switch this on, you can see our short circuit on the 15 volt rail. I'm going to unplug B1, 2 and 3 one at a time from the bottom of the power supply to find out which one is the one where that short circuit is originating. So that's, I think, B2. Don't think it's going to be that one, but try it. Not that one. B2 and 3 are both unplugged, but the short circuit still exists, so it's presumably coming through on B1 or some other route. Let's have a look. Unplug B1. Aha. So whichever is the 15 volt connector on B1 is being shorted to ground when we switch the switch on. Let's see which one it is. There's more than one 15 volt. Right, that first pin there. Right, so it's a red wire here, the first connector on B1. I'm not sure which end is which because it's not easy to see. Okay, that is B1 pin 10. Right, just here. So B1 pin 10 is our short to ground when that switch is on. Right, a little bit of progress. Well, unless, of course, that is normal operation and that load is normal, 1 ohm. No, can't believe that. Even if you had some big capacitors and motors, I still don't think you'd see an ohm on there. So we need to work out where B1 goes, and particularly pin 10, and follow it through. We're likely to find a short circuit tantalum capacitor, I think. I might cheat just a little bit, you know. We can take these boards out. So I could take each of those out and see if our short circuit disappears, and at least then we could eliminate a whole heap of circuitry. Okay, so I've put a wire on the 15-volt line. So there's our short circuit of a fraction of an ohm. So really can't believe that's normal. Let's see if we can clear that by removing some of these boards. And if not, well, at least we've eliminated some circuit. So we take this metal clamp off, which includes my AV output circuit there, which incidentally does use a 15-volt rail. So, you know, in theory, my circuit could have gone short circuit, but it won't be. Right, so short, let's take out, this is the syscon panel. Okay, our short circuit's not on syscon. Whatever board this is, maybe audio, not quite sure. No, servo, that's servo. Not there. Ah, I did have a fault on that one. There we go. Many years ago. My first repair on this included replacing that IC, it's an op-amp, which had gone nuts, and the result was that the drum was running, no, the capstan was running far too fast. So I replaced that way back when I first worked on this machine. Oh, must be about 20 years ago. Okay, that board's in. Next one, I think, is one of the video processing ones. It's got the sharpness control on it. Not that one. Right, next I think is the tuner, maybe? No, it's not tuner. Yeah, it's IF stage, I think. Can we get to some of these boards down here? I think there's audio is there somewhere. Okay, well, let's put this clamp back on because it wasn't any of those. I don't yet know how to take that board out. There's a clamp in there of some description. Similarly, this one, I'm not quite sure. But what I am going to do for a moment is unplug these cables here, which will isolate the front panel. Or at least partly isolate it. That's a much higher resistance. What's that saying? 16 ohms? That's probably normal load. When I refit this connector, which, like all these connectors, is evil and really hard to refit, really struggling to refit that connector. I might leave it off for a moment because it's only concerned with the tuner and those settings, and I don't think that matters for a moment. So let's just leave that off and see what happens. Now let's take my multimeter off that, or put the multimeter into volts mode and see if we get our 15-volt rail. $15 volts, and it stays on. Could I even go as far as getting the play button to work? Not letting this short to anything. Yes. All right. That's a huge amount of progress. So here's our panel that has the connector, which when fitted short circuits the 15-volt rail. So I just need to take this off. I might get rid of this so I can see what goes where. But no, it's just this cable. Is it just this cable goes to there and there? I haven't worked out from the schematics yet which of these has got the 15-volt line on it that's giving us the short circuit. But hopefully it'll become fairly obvious when we take the board off. Now, of course, you could say, well, I don't need this board anyway, because this board is for the tuner, and we're never going to use it, and that's true. But, you know, this is an incredibly rare video recorder. Working examples of this video recorder, there's probably, you could count them on your hands how many there are left on the planet. So it just feels just not right to just say, oh well, let's disconnect it and not worry about it. If it's possible to repair it, I will. If it needs a, you know, an IC or something, then that can't be done. But it's such a good short circuit. I think it's going to be a fairly obvious fail. Okay. Well, there's not much to it, is there? So it's quite likely, isn't it, that one of these tantalum capacitors has gone short circuit. Okay, so let's try them both. That one appears to be okay. This one's a bit harder to get to. That, I think, is our component. Okay, we have a fraction of an ohm across there. If I snip one of the legs, does the short circuit stay? I'll see if I can desolder it actually. And let's see if it's across the capacitor itself. There we go. So it's 10 microfarad, 35 volt. And one final check. There you go. So a quick final check. So oops, get the insulators off there. And it's very low resistance indeed. About 100 and so milliohms. 10 microfarad, 35 volt. I'll replace it, of course, with a normal electrolytic capacitor, not a tantalum one. Good. So the two components that caused the failure were those two, and of course it took out a fuse as well. Fitted a 10 microfarad 63 volt capacitor in there, and being wary of the polarity. So now I should be able to reassemble this. I will get it reassembled. It's just a little fiddly. You have to line up the LEDs and everything else. It's just fiddly. I'll get there. Okay, that's all reassembled. The buttons feel good. Except that one. Oh. Now let's get it right. I bet they struggle to build these in the factory too. There's an insulator on this under this screw. That's really important. Was that colliding with this tantalum capacitor perhaps? Ah, maybe that's the reason. When I moved it to test it. Yes, the placement of those capacitors might have been very critical. Not a very good layout on the board, is it? No, I'm nowhere near that capacitor. Maybe it's a resistor next to it that got squashed. I know it doesn't matter, but, you know, I feel like this is not just a video recorder for my business. It's a little bit of history. It's an artifact. And someone's got to take the trouble, haven't they? When I'm gone one day, hopefully somebody will treasure these machines.
Not me. Or me.
Or me.
Ah, I've pulled a connector off. That's a nuisance. I'm not sure where that goes. Okay, I'll have to find out. It's important too because it's the connected to the power switch, so we really can't miss that out. And it's a single pin. It could be anything. It could be like over here. I don't know what it is. Oh dear. We'll have to look at the schematics and find out. I've been struggling to work out where this wire goes, and I've had to take this control board off. I'm fairly sure that that wire goes to the other side of the pin that's here. It's right there. But it just doesn't seem very convincing because there's no yellow socket for it to fit into. But that's marked 1B, and it does appear on the schematics. They could have done a better job of that, couldn't they, really? There's nowhere for this plastic peg to seat. Feels like a bit of an afterthought. Okay, that does seem correct, albeit not a pretty design. So I should be able to reassemble this control panel now, and hopefully it will all work. Right, I've not refitted all these screws yet. I just need to test it first. So let's just switch it on. Playback. Stop. Rewind. Fast forward. and power down. Looks good. Let's see if we get a picture out of it. I'll put these screws in the front now. Okay, let's see if we get picture and sound. It's sometimes not good on this format actually, because interoperability between machines was pretty much not guaranteed on this format. It's tracking, that is. Okay. Do you have sound? I have pictures, which are really not bad, but struggling for sound. Okay, I'll have to find out what's wrong there. Okay, well the fault is not with my bit of wiring to the output socket, because if I go there to the output you can get the hum, so there's no audio being supplied. So the fault is further back, so there's no audio to the board that has a modulator on it. Which is the audio board? Is it this one? One of those? Oh, what a nuisance. Okay, this is the audio board here. TON, it says. I'm not quite sure how to get it. It's a bit awkward. But initially we need to just look at some of the connections at the bottom on the main board. I just need to check it's got power and see if we can see anything coming over the output, or maybe just stick my finger on the output and see if we get mains hum come through. So the trouble is it's a bit awkward because I can't roll the machine onto its back. That's where the connectors are. It's going to be a little bit awkward running the machine on its side. I'm not sure if it likes that, but I don't have a lot of choice. Okay, so this is the bottom side of the TON board, and this connector here goes to the head. So we have the two sides of the head and a ground point there, and the output is on pin 28, which is this screened wire here. So let's just switch it on. Let's inject a little noise into there and see if we can find out. If I inject noise into there and it doesn't appear on the TV, then that implies we have an open circuit issue somewhere. If we can get it to play sideways. Okay, it doesn't like playing sideways, and I don't blame it. Right, inject some noise into the output. Yeah, I can hear that. Okay, what about onto the head inputs? Yes, so it implies we're not getting anything from the head. That's probably a connection problem with the head then. Okay, let's have a look at the audio head. Or the other possibility is there's no audio on this tape. So either we've lost contact with the audio head, or the possibility is that there's no audio recorded on this tape. I hadn't really considered that. I don't have many test tapes for this format. Where is the audio head? Okay, there's the audio head there. And the wiring goes straight down into the chassis. You can't really get to much. Jammed in behind the pinch roller, a bit awkward to get to. I'll just try another tape, I think, for a moment. Okay, let's try another tape. It'd be embarrassing for all that was just because there was a bad recording, but let's try. I don't know what, if anything's on this. Oh, it doesn't sound very happy. No, it doesn't sound very happy, does it? It's scraping on the cassette lid. It didn't like that tape much. And I don't think we got sound then either. Try this one. That's not tracking. And there's still no sound. I'm just going to try cleaning the audio head that's here. It's really awkward to get to, but let's just try cleaning it in case there's a huge lump of something on it. Well, that's different. What I may have to do is take the pinch roller off to give myself a little bit of access to the back of the audio head. Right, the wires from the heads, which are here and really hard to get to, actually come through to this sort of interface board here. So I can kind of get to things here. I can check that, well, this presumably is supposed to meter through to the audio board at the back. I don't know which of these sets of wires is the correct one, but you know, there's only two to choose from. So having worked that out, I will, for the time being, put the pinch roller back. Even fitting the pinch roller is a bit fiddly because it collides with this piece of metal here. They didn't need to put that right in the way. Right, I'll put it back onto its base, refit that circlip, and then we can do some metering out on the these wires. Okay, there's a yellow and red wire here, and the yellow and red wire on the ton board. So looking at the yellow first. Oh, is that it? Yeah, and then the red. And we're reading the 300 ohms or so, which you'd expect from a head. So we have contact from here to the audio board, and we looks like we have contact from here to the head. Let's unplug the connector on the back of the ton board. Right, so unplug that. So we should just be metering the head here. So that's the audio head. So we're connected to the audio head, and let's just look at this is the control head. Yeah, a couple hundred ohms. So that's illogical. These contacts closest to us are the audio. The head is wired to that properly, and that's wired to the audio board properly, and the audio board is amplifying. So why are we not getting any sound? So look, we've got the audio system's working, but we have no sound on any tapes. Makes you wonder if the audio head is not in contact with the tape in the right place. Honestly feels like the audio head is missing the tape. So when that engages there, surely this is on the tape, and it's not like it's got a massive misalignment. This was all working last time I used this machine, and all these points have not been fiddled with. And if this wasn't engaging, then the pinch roller wouldn't be engaging and the machine wouldn't work. And the audio head must be engaged properly, otherwise we wouldn't get capstan lock. Well, in desperation, I've cleaned the audio head again. Actually, there's quite a lot of crud on it, but really mostly in the middle, not where the actual head tips are, or head, you know, the head surface. I'm just not understanding this. Yeah, if I inject loads of noise into the audio head, that happens, and if I inject loads of noise into the control pulses, we lose capstan sync, exactly what you'd expect. So it just looks like there's no recording on the tape. You'd get some hiss. At this volume level, you'd hear hiss. It's baffling, isn't it? It's like the audio head has gone well, it hasn't gone open circuit, but that there's a default developed in the audio head. That's what it's feeling like, however unlikely that is. Just now, I switched it on, and for a fraction of a second there was sound. I'm beginning to wonder if we might be back to a fault in the audio board. I wonder if we're in mute mode. There is a mute signal. Did you hear that? Aha! There is sound for a moment when I switch from fast forward to play. Like from stop to play. Yes. then it seems to fade away. Listen. We had that earlier. And the sound's coming back.
Ich habe unruhige Nächte. Ich bin sehr impulsiv. Ich kann kränken, aber nicht kränken. Sie wissen am liebsten nicht kränken, weil ich böse bin.
There's a little bit of hum on it. Even that's fading.
Ich bin ein guter. Es ist ein faszinierendes Jahr. Ich habe selber eine Tochter, die Skorpion ist und die ist wunderbar. Und vielleicht, weil das Tierchen ist, hat dieses Gift.
Interesting. Let's try that a few more times. Stop, play.
Wie steht es mit Ihrem Kreislauf? Frau Rück, wie steht es mit Ihrem Kreislauf?
What's going on?
Sie sollten auf den Kreislauf im nächsten Jahr ein bisschen aufpassen. Ja? Wie steht es mit Ihnen?
So, is it actually an electronic fault that has now cleared itself? Capacitor trouble? It seems to have fixed itself, so it may well be a fault somewhere on the audio board, which is going to be almost impossible to fix, because in order to work on the audio board you need the extender card to get it out, and of course we don't have that, and furthermore the fault has gone and cleared itself. So we might just have to leave that fault if it really has gone away.
Drehen, weil das Publikum verlangt es. Ich weiß, wenn Sie... ich weiß, wunderbar.
Okay. Was ist das für ein Tanz?
Was das für ein Tanz ist? Ja?
Walzer oder?
Ich würde sagen, wenn ein dritter Stuhl da wäre, setz dich hin. Ein ganz toller...
Well, it's now working reliably. I can press play and I get good picture and sound in a moment. And actually, very good picture. It's remarkable how good it is when you consider that it's actually using an even higher tape density than N1700, let alone N1500, from essentially the same kind of cassette, albeit a higher grade of tape. Now, how many of these machines are left working? Oh, not many at all. This is exquisitely rare. It was the only model, essentially, of this format. And I would be surprised if there's more than maybe 5 or 6 of these machines left on the planet in good working order. So I'm really pleased to have got this working again, and I can run the customer's tape on it very soon. Right, I hope you've enjoyed working on this incredibly rare video recorder. If you like this sort of thing, do let me know. I'll do plenty more content on audio and video technology in the near future. Bye for now. You know, I said they're incredibly rare. Guess what I've got in my store here? Buried down there, can you see it? There's another one. I've never really looked at that machine. Let me know if you'd like me to work on that video recorder in a future video.